Hello everyone, I'm Jennifer Bronze from the Light and Health Research Center at Mount Sinai. I've been working in lighting for 25 years, so I'm going to share some information about how I go about selecting circadian effective lighting. As you saw in video 4, implementing UL 24480 has several steps. In this video, we're focused mostly on step 2, selecting the luminaire, also known as light fixture. I'm going to touch on several of these points here in this video though. When I start a new lighting design project, I ask myself whether to use only overhead lighting, also known as general lighting or ambient lighting, or should I add a layer of light that is only used during the time when I need my max output. As you'll see here, this designer used a layer of blue overhead lighting in the ceiling with special programming for use in the mornings. Alternatively, you might consider adding a layer of circadian light, like with something like this plug-in task light that we built for a GSA field study. We expect to see more products like this in the future. The one on the right is one I'm using in people's homes now, so residential and commercial products. Layers of light are really helpful. You can really reduce your power demand the closer the light source is to your occupant's eyes. But glare is an important consideration when you have something glowing, especially something like a vertical panel that might be built into furniture. There's a particular chart that I use all the time when I'm selecting luminaires. It's called the candle power distribution curve. This is a polar plot with lines radiating out from a center. The lines refer to angles of light, and the circles indicate the intensity in units of candelas. This curve in red here shows the angles and intensity of light as it's coming out of the center of the fixture, or in this case, it's actually a bare bulb. I can tell from this diagram that this lamp emits light evenly in all directions and sends some of its light upward above the center of the light source. So I start looking at these graphs to figure out where the light comes out of the light fixture. Also shown in red is the different cuts through the fixture, laterally, some dashed, some in a solid line, and sometimes they might use different colors to indicate the different cuts, either laterally or horizontally and vertically. When I'm doing my lighting design, I might also consider luminaires that send all their light downward, also known as direct distribution. As you'll see from the blue line in the curve on the left, this luminaire doesn't really spread its light out very far. If I want to get light in people's eyes for circadian entrainment, I'll probably want a wider distribution like the blue curve in the middle here. The curve on the right shows a luminaire designed to aim light at a vertical surface, known as a wall wash. This red circle shows the view in plan, and the blue circle shows the view from the side, kind of an elevation view, and that's why we call it an asymmetric wall wash. It's setting the light mostly in one direction. You might also consider a layer of light that is indirect, that is, shining its light upwards. Usually that's a pendant luminaire, but it could also be a wall sconce or furniture integrated solution. You'll see two interesting things with this candle power distribution curve on the left. It only shows the top half of the plot because it only sends the light upwards. And the shape of it isn't just a blob or circle, it's kind of more like a butterfly wing, or in this case we call it a bat wing distribution. That means that this light fixture has a prismatic optic on the top that spreads the light out to the side. Bat wing distribution also allows you to space your pendants further apart, which is good for energy efficiency and minimizing material cost. The curve on the right is an interesting one. Not only does it have indirect distribution, but it shows direct distribution. It's a direct-indirect pendant. So we can see that it has a bat wing uplight, but even a downlight as well. And the size of the yellow shaded area indicates that more of its light is going downward than upward. So we use these very often, these kind of graphics, to figure out what kind of light fixtures we should use. One more point I wanted to make about indirect lighting. Your ceiling must have a light finish color in order to reflect the light down into the room. I have seen instances in which people used a black ceiling for indirect lighting, which is really a very ineffective way to put light in a space. I keep using the word layers of light. Consider whether all of your circadian light needs to be, or can it be right close to your occupants, such as this desktop luminaire that I'm showing in a drawing and here in the photo, and whether it should be a saturated blue source or a whitish light source. A saturated blue light source would use less power to achieve circadian stimulation than a white one. If you are using ceiling mounted lighting for your circadian lighting effects, you can check out this publication here that I'm showing, in which we have some design tips. We recommend that the vertical illuminance, the light on a vertical surface such as your eyes, be at least 65% of what is showing on horizontal surfaces, that the ratio be 0.65 to 1 or greater. So in these diagrams here, this troffer gives me a ratio of 0.7 to 1 and it would work. A direct-indirect pendant, 0.66 to 1, that would work. This indirect pendant, 0.72 to 1, that would work. But this downlight here is only 0.05 to 1. It's probably not going to be very effective for providing circadian lighting. And now while we're on the topic of power demand, we can go into more detail in just a moment, but I just wanted to say that a bluish white light source can typically require fewer watts for equivalent circadian stimulation compared to a light source that's warmer in color. But there's a lot of aspects of design that a designer needs to balance, and the appearance of the space might not be appropriate if you're with very, very bluish white light sources. But we did want to make a point about power demand at this point. Stay tuned for more about color spectrum in just a moment. In one of your later steps in the lighting design process, you'll be doing calculations. All the information in your candle power distribution curve can also be shown in a table rather than a graph. And that same information can also be communicated in a standardized file, a photometric file known in North America as an IES file. IES files are found on your luminaire manufacturer's websites or from their sales reps, or may even be integrated into your photometric calculation software. The explanations about how to read the numbers in the IES file can be found in an IES publication called LM63. And I'll refer you to video number 7 for more information about the circadian lighting design process. In video 8, for field measurements, it's presented by me, you'll be learning how to compare what you're calculating in your software to what we actually find in the field. When you're considering luminaires for circadian lighting, there's other technical information you're going to need. So in preparation for the later stages, I want to introduce you to spectrum. So when you're choosing luminaires for circadian effective lighting, you're going to need to keep track of colors of light, the spectrum of light. It refers to the output in terms of wavelengths, which we perceive as color. Now I'm going to show an example here of a spectral power distribution graph that's showing the output of a light source between 380 nanometers to 770, 780 nanometers. So this is not which angles the light comes out of the fixture, this is what colors are emitted by the light source. So when I hear the word spectrum, I think of color output. Spectrum contributes not only to the way we see colors in the space in terms of vision, but spectrum also influences our circadian entrainment. There's some background information on spectrum from the U.S. Department of Energy. And for more information on the importance of spectrum with circadian entrainment, see video 6 in this series. Now, I do not initially select lighting based on SPD when I'm choosing luminaires, but I do collect this information when I'm trying to compare a couple different sources to see which one is going to be particularly effective for the circadian system. Now, what if your manufacturer cannot provide the spectral data that you need for your calculations? That may be because they aren't sure whose LED chips they're using, or it may vary over time, or there may be supply chain issues. We want to warn against assuming that the same correlated color temperature has the same circadian characteristics. We'll go into detail in video 6 about that. If you're running into trouble getting SPD information from your manufacturers, you might want to consider buying a small spectroradiometer, making your own measurements using a luminaire provided by the sales representative, a sample. And that's quite often what I end up doing when I run into trouble finding more information. When you're selecting luminaires, you also need to select lighting controls to turn them off and on or dim at various times of the day. Now, back in the early stages of your process, you were working with your client to learn, well, what time of day do people come into this building? What time do they leave? And what time of day do I need to have high circadian stimulus, sort of medium and low levels? And as you're going through different circadian stimulus, you might have different luminaires or layers of light that are turning on at different times. So we want to point out that you'll need to consider lighting controls in your design. They could be complex, such as a scene controller, which will dim up or down several layers of light at one time and can crossfade much like theatrical lighting on a schedule. Or they could be a simple time clock that just turns off a dedicated circadian boost layer at your scheduled time, say noon. Controls that provide color tuning are optional. Color tuning is lighting that can shift in color output between a bluish white light early in the day to a warmish white light late in the day. You can achieve circadian entrainment with static white light without using color tuning and a lot of controls. So to learn more about controls, there's a great industry organization that has a lot of training content, the Lighting Controls Association. Thank you for watching this video. In the next video, you'll learn more about how to use that spectral information in the spectral power distribution to perform circadian stimulus calculations.